we're going to look at GENSETS, understand how they work, the maintenance required, and how they tie in with a hybrid and off-grid system. Now, if you haven't, please hit the subscribe button and like and comment on these videos. It allows us to continue making this free content. All right, let's get started. In this training video, we're going to break down how GENSETS work, how to install and maintain them properly, and where they fit alongside solar and batteries in an off-grid and hybrid environment. Here we go. Now, this is the agenda. What is a GENSET? We can look at the key components, any applicable Australian standards, a quick guide. We can look at 2-pole versus 4-pole, cooling, water-cooled versus air-cooled. We're also going to look at the installation and commissioning essentials, maintenance and inspections, safety fundamentals, off-grid deployment and logistics, solar, battery and GENSETS under a hybrid renewable energy system scenario. Here's the plan. We're going to cover what a GENSET is, the key components, the relevant Australian standards, and some practical choices like 2-pole versus 4-pole and 1500 RPM versus 3000 RPM. We're going to be comparing cooling options. We're going to walk through installation, maintenance and safety, then finish off with off-grid logistics, airflow and overheating, hybrid solar battery GENSET control, biofuels, and even remote monitoring. Let's get stuck into it. What is a GENSET? Effectively, it's a self-contained power system, engine and alternator. It delivers AC power for emergency backup, remote and off-grid use. Now, typical subsystems include prime mover, which is either diesel, petrol, gas or biofuel, the alternator, which is the AC generator, the control panel, protection, monitoring and the auto start, fuel system, tank lines, filtration, cooling and exhaust systems, base frame, the skid and the vibration isolation. Now, a GENSET is a self-contained power system, an engine called the prime mover, and it spins an alternator to produce AC electricity. And they're used in a variety of situations as backup, remote sites, construction and full off-grid setups. Now, under the hood, you've got the engine, alternator, control panel for the protection and auto start, a fuel system with filtration, cooling and exhaust, all on a base or a skid with vibration isolation. Now, the prime mover converts fuel into mechanical energy. There's an alternator, and this converts mechanical into electrical energy. Control and protection, so we're talking about monitoring, metering, auto start, stop, and safety trips. We've also got a fuel system, which consists of the tank, day tank, pumps, filters, water separation, cooling system, radiator, airflow or heat exchanger, fans. And of course, the exhaust system, radiator, airflow, or heat exchanger fans. Now, all these things have to be taken into consideration. One, when selecting what is the most effective GENSET for your application. And two, the most effective GENSET also depends on where it's going and where the exhaust is actually going. It's a really important point, especially when it comes to off-grid scenarios where you don't want to foul any kind of water tanks that may be the primary or only source of water for the occupants. It's a really important point. You have to take into consideration prevailing winds and where the actual diesel exhaust is going to go. Let's get back to it. So there's some Australian standards, and here's a bit of a quick guide. You're talking about 3010, you're talking about AS 3000, and a 4509 and a few others. And of course, there's applicable cabling standards as well, such as AS 3008. Pole configuration, 2-pole versus 4-pole. Now you can see in this little table, we've got the attribute, 2 poles versus 4 poles, and the differences. For example, when it comes to longevity, the 4-pole is going to last longer because there's a lower mechanical stress, which leads to a longer life. The rotor speed, if you're looking at frequency, is much faster than in a 2-pole compared to, say, a 4-pole. So the general rule of thumb is a 4-pole GENSET is going to last longer than a 2-pole. Now, generator speed is tied to the number of poles. At 50 hertz, a 2-pole alternator runs at 3,000 RPM, where 4-pole runs at 1,500 RPM. Two-pole machines are smaller and lighter but noisier and wear faster, great for portable or light-duty applications. Four-pole units are generally heavier, quieter, and typically last longer, and they're ideal for stationary sets in prime or standby duty. Now, prime and standby, there's two different ratings. The prime rating is the rating of a genset is running continuously effectively, or almost continuously, whereas standby, the rating may be a little bit higher because the genset may be running, say, 4 or 5 hours a day or a certain time period, but not continuously. Prime ratings are always lower than standby ratings. Now let's look at the engine speed. You've got 1500 RPM versus 3000 RPM, and you can see with this particular table, heat rejection, for example, is easier to manage with a 1500 RPM unit than, say, a 3000. Obviously, the acoustics, 3000 RPM is definitely louder and considerably louder. Now, the loudness of gensets is measured in decibel, and this is a logarithmic scale. So the difference between, say, 55 dB and 65 dB is considerable, and you must take that into consideration as part of your selection criteria. Now, engine speed sets both acoustics and longevity. 1500 RPM is quieter, easier on components, and better for continuous or prime duty with longer service intervals. 3000 RPM is compact and cost-effective with a higher power density, but louder with shorter intervals, and it's best where portability and intermittent use matter. In other words, not for a situation where a prime rating is required. Cooling. Water-cooled versus air-cooled. Straight off the bat, a water-cooled system is a more robust system than air-cooled, and they're generally a quieter a genset. Cooling is critical. Water-cooled sets handle higher continuous loads, hot climates. They're more reliable, but they do have more complex radiator, pumps, hose setups. Air-cooled units are simpler, compact, but can struggle in high ambient temperature under sustained heavy load. And that's because they're air-cooled. So you can imagine the situation, say, in some remote areas of Australia or around the world where you're getting some fairly hot conditions, over 40 degrees centigrade or over 110 degrees Fahrenheit. An air-cooled unit really will suffer, and its ability to deliver sustained energy to loads is severely reduced compared to a water-cooled unit. Now, we're looking now at installation and commissioning, the essentials. Now, site and mounting. You're looking to level the site. You must level the site. You need a rigid foundation, anti-vibration mounts, and access for service. This is really important when you're actually positioning or locating a genset to allow for adequate access when it comes to maintenance and service of the unit, which is required because we're talking about moving parts, so there's a lot of things that need to be maintained. Fuel is really important. We're talking about potentially bundled storage, polishing, filtration, day tank, and all the compliant pipework. And of course, there's the electrical, correct earthing, bonding, compliant changeover, ATS, automatic transfer switch, cable sizing, and the multiple earth neutral. And of course, there's ventilation, cool air intake and hot air discharge, and you must avoid recirculation back pressure limits. Of course, there's a commissioning component, and you must take into consideration the electrical tests, the protection checks, load bank test, and the documentation. When it comes to actually installing the genset, you really require a level, rigid foundation with correct clearance and service access. It's really important. And fuel storage must be compliant. Think bunding, day tank placement, and good filtration. Fuel filtration is incredibly important. Electrically ensure correct earthing and bonding, a compliant ATS or changeover gear, and appropriate cable sizing. Now, ventilation matters, so you need to bring in cool air and expel hot radiator air without recirculation. This is a real problem when people start putting gensets into existing buildings without adequate airflow. the worst thing they can do is recirculate the air. So you're drawing that hot air that's expelled from the genset back through the system. It really reduces efficiency and also reduces the lifespan of the genset involved, whether it's air-cooled or water-cooled. Commissioning should include protection checks and a load bank test to confirm performance and temperature stability. And you've got to document everything. Effectively, a load bank is a resistive load at a certain kilowatt rating that puts the genset through its paces to make sure that it will cope with sustained loads at that particular level. So there's a lot of maintenance with gensets. Again, as I mentioned before, there's moving parts. There's fuel, there's oil, there's air, there's all these filters that need to be checked, and you need to document your maintenance schedule. So you're looking at service intervals per OEM, hours per calendar, engine, oil and filter, coolant, belts, valve lash where applicable, fuel, water drain, filter, water separator, fuel quality, and storage hygiene. Very important. Still under the maintenance and inspection, you're looking at electrical, so insulation and winding checks, control firmware, breaker exercise, batteries, the state of charge, electrolyte if flooded, terminals, load bank testing to verify kilowatt and temperature stability. Now, batteries is a big one with gensets. If you're using a genset in a situation where it's not called upon regularly, those batteries can lose their state of charge fairly quickly. So if you're talking off-grid, you really need something, an inverter charger that allows you to do a genset exercise schedule. So in other words, for example, the genset turns on once a month for at least 15 minutes and full load is shifted to it. Really important to remember, especially with diesel gensets, that you don't want glazing, so never run a diesel genset under 30% load for any extended period of time. They just don't like that. They want to be loaded up to 80-85% of their capacity on a regular basis. Reliability depends on routine maintenance. Follow OEM hours or calendar schedules. For the engine, oil and filters, coolants, belts and valve lash where required. Fuel, drain water, replace filters and keep storage clean. Fuel hygiene prevents a world of pain. Now, there is certain bacteria that can build up in fuels if they've been in their in a tank for a long time. So just be aware of that. There are additives that you can buy, but it's just something to be a bit aware of, especially with the larger remote tank situations that some gensets require. Electrical, check insulation resistance, update controller firmware and exercise breakers. Batteries, monitor charge state and keep terminals clean. And run periodic load bank tests so you know the set delivers its rated kilowatts without overheating. Now we're going to be looking at safety fundamentals. So when you're doing any work around gensets, you need your PPE. So we're talking about eye, ear, hand protection. So be really aware of hot surfaces. Be aware of exhaust routing and carbon monoxide risk. And we're not talking carbon dioxide here, we're talking carbon monoxide, which is a real killer and has been responsible for quite a few deaths around the world. So take that into consideration. So make sure there's the CO risk management, no recirculation, isolation lockout procedures, and test before touch. If the genset is indoors, it must have more than adequate ventilation at all times. Use lockout, tag out, and test before touch. Maintain clearances and have the right extinguishers on hand. Class B for fuel. And control noise exposure with acoustic enclosures or barriers where needed. Now we're going to look at off-grid deployments, so basically standalone power supply systems here and how a genset comes into play there. 99% of off-grid systems of any size do have a fossil fuel component, and invariably it is a diesel genset. So think of cattle stations, anywhere that's prohibitively expensive to connect to the grid. In other words, the grid is out of the question. You're looking at these off-grid systems. The genset's always there. I'm not talking about signage, which may just require a battery and a solar panel and no genset because the loads are quite small. But anything for sizable loads like a household or a cattle property or anything that's pulling a few amps, you will need a genset there. Otherwise, it becomes pretty cost prohibitive if you're looking at that the energy storage, upping the energy storage capacity. So we're going to be looking at sizing strategy, the right size for average load, avoid long light load operations. Batteries, always use best to shave peaks, run the genset at efficient load to charge the batteries. Auto start logic, start on state of charge, kilowatt or time, warm up, cool down, timers, exercise runs. And I mentioned this before, exercise runs are really important, especially when the genset is not called upon frequently to service loads. Think an off-grid situation in summer when there's a lot of solar gain and the genset in a lot of cases is not needed. It still needs to be exercised regularly. Fuel logistics is really important. Storage capacity, quality control, seasonal demand planning, environmental, spill control, noise, emissions, and derating for heat and altitude. This is a really important one. The higher you go, the more derating the genset is subjected to. So a 50 kVA genset's ability to service the load at sea level is severely reduced if you take up to 1,000 metres or more. It does play a role. In off-grid systems, sizing control strategy are everything. Avoid long periods of very light load. Diesels prefer to work in an efficient band. Use the genset to charge batteries at a healthy load and let the BESS cover peaks and low load periods. Configure auto start on state of charge, load all time, and include proper warm-up and cool-down. Plan fuel logistics for seasons and access and apply derating for heat and altitude. Logistics, getting gensets to site. Flatbed tilt trays, trucks or oversized for small sets, and oversized loads for really large units. In some instances, you're using a crane, so you'll have to look at certified lifting points, spreader bars, weight, and COG checks and lift plans, which is very important. Mounting, skid or base tank, concrete plinth, springs or rubber isolators. And of course, you have to take into consideration access, clearance for filters, radiator, removable panels, exhaust service access. Logistics, getting gensets to site, continued. Plan delivery as carefully as you plan your electrical works. Smaller sets can ride on a flatbed truck, but the larger ones may require an oversized load and all the traffic requirements that come with that. Cranes are another kettle of fish. You'll need your full lifting plan in place and a lot of permits or even some traffic management depending on where the crane is situated. Just take those things into consideration. Lift with certified points and spreader bars. Checking weight and centre of gravity. Mount on a skid or base tank atop a concrete plinth with isolators and keep access panels and exhaust runs serviceable. Now we're going to be looking at airflow and overheating. And of course, and I've mentioned it a few times, avoiding hot air recirculation. Inlet, outlet. Separate cool air intake from radiator discharge. Ducting is needed. Pressure drop. Make sure to take into consideration the size of the grills and the louvers to limit static pressure. Check for fan curve, which starts to get fairly technical. Hybrid renewable energy systems, PV, BESS and genset. We have to take into consideration the operating modes, the genset as a charger, the PV BESS to serve variable loads. There's all these controls, EMS coordinates, state of charge targets, load sharing, mini run times, black start. Now the benefits, lower fuel burn, fewer engine hours and quieter operation. In a hybrid situation, the genset is best used as a controlled battery charger. Run it in its efficient window to bulk charge, then hand off to PV and batteries for variable loads. And this, of course, depends on the kind of battery that you're charging. So obviously a lithium battery has a different charge regime compared to, say, a gel-based lead-acid battery. Now, an energy management system coordinates state of charge targets, load sharing, minimum run times, and black start behaviour. Done well, you'll really cut fuel burn considerably, of course, engine hours and noises, without sacrificing reliability. GENSETS in off-grid solar systems. So in this situation, we're looking at backup supply when PV is insufficient, night or cloud. Battery charging and optimum engine load to reduce wet stacking. Islandy operation with proper frequency voltage controls. Harmonic management when feeding sensitive loads. So there's a few factors to think about. In solar off-grid systems, the genset fills the gaps night, bad weather or extended loads. Ideally, you set your inverter charger limit so the genset isn't overloaded and the charge profile is correct. Maintain stable frequency and voltage and watch harmonics if you have sensitive electronics. Now, the reality is most good gensets, especially the diesel 1500 RPM water-cooled, have a total harmonic distortion of better than the grid, less than 4%. So running sensitive electronic equipment in most cases is really not an issue, but it does depend on the quality of genset that you actually select. Biodiesel, FAM. So FAM stands for fatty acid methyl ester. So it's a biofuel that's a combination of vegetable oils and methanol. Lower net CO2. Check OEM max blend, e.g. B20, and watch for cold flow issues. HVO, renewable diesel, is another option. It's a drop-in for many engines. It's a cleaner burn, better storage stability. There's also straight veggie oils, example coconut, which has a very high viscosity, so you need to preheat and possibly have a dual tank conversion injector. There's coking risks. So in other words, if you're running straight vegetable oils, they're very solid. They'll have a high viscosity, like molasses. So there can be an issue with the injectors actually blocking up. You can use preheating situations, or you can start the genset on another fuel like a biodiesel or straight diesel, get everything heated up, and then switch over to vegetable oils. And on the finishing cycle, you reverse that process. That's one of the options. There's a few. It's a very interesting area. Now, biogas, LPG, and natural gas. Cleaner combustion needs appropriate engine compression ratio, and always verify material compatibility, seals, hoses, and adjust maintenance intervals. Now, it's an interesting one here. Some of the fuels that they mentioned, the natural gas, LPG, biogas, can be a bit harsh on fuels. So you have to find compatible materials that don't break down, and it's something to be pretty aware of. Now, biofuels can lower net emissions, but compatibility matters. Biodiesel FAME is common, but you've got to check the OEM's max blend and be mindful of that cold flow behaviour. HVO, or renewable diesel, is often a clearer drop-in option with better storage stability. Now, HVO is hydro-treated vegetable oil, and it's made from waste materials like veggie oils and animal fats. Straight vegetable oils like coconut oil are far more viscous, and they typically require fuel preheating and dual tank conversions, and they can increase coking risk if not engineered correctly. Gas fuels, biogas, LPG, natural gas burn cleaner but need engines with appropriate compression and management. Whatever the fuel, verify elastomer compatibility and tighten maintenance intervals until you've characterised the setup. Now, acoustic enclosures with line panels and baffles is an option. Exhaust silencers, critical, industrial and flexible connectors, vibration isolation between set and slab, site layout, distance and barriers, and reduced perceived noise. Remember, noise has a logarithmic component, and as I mentioned before, the difference between 55 decibels and 65 decibels is considerable. Noise reduction techniques. Now, to keep neighbours happy and crews safe, combine acoustic enclosures, quality exhaust silencers, and proper vibration isolation. Site layout helps too. Distance and barriers reduce perceived noise. On the operations side, remote monitoring is a game changer. See fuel level, kilowatt, engine hours and alarms in real time and move to predictive maintenance instead of reacting to failures. This is a very interesting area where you're looking at predictive maintenance, and the ability to monitor the set in real time is becoming very, very important. It's better to be proactive when it comes to gensets than reactive, especially in situations where the genset is servicing critical loads. So remote monitoring, you're looking at telemetry for alarms, fuel level, kilowatt hours, and predictive maintenance. Now, future tech, hybrid controls, ISO 8528-5, dynamic performance focus, hydrogen fuel cells, AI, ML diagnostics. Conclusion. Now, here's a short version. Pick 4-pole, 1500 RPM water-cooled for those more sustained loads. Anything else, you can go maybe 3000 RPM water-cooled or air-cooled. Design airflow, exhaust and mounting before site day. It prevents 90% of headaches. Use the right standards and check for amendments. It's really important to check for amendments with the standards. Hybridize with PV and BESS so the genset works efficiently as a charger, not a constant noisemaker. And lock in a maintenance plan with remote monitoring for real reliability. Now, here's an example of some of the checklists that we use at Greenwood. This is first one is a logistics and delivery checklist. And the second one is a pre-designed checklist. So some of the checklists we use include the two previous ones: and install and commissioning checklist, ventilation, airflow, electrical ATS, maintenance, safety and compliance, off-grid and hybrid, biofuels, noise and community. So if you want to use the templates that we use at Greenwood, please subscribe to Greenwood Academy, like and comment, and tell us what else you want to see. We really appreciate the feedback. And best of luck on your next project. See you next time.